All right, welcome everybody. Today we're going to talk about pre-calc lesson number 24. So we're still talking about rational functions. Our ultimate goal is to be able to create a graph of a rational function from scratch using all the key points we've been going over for the past few lessons. But before we get to that, we're going to work backwards. Given the graphs, we're going to go ahead and try to write the equations both in factored and standard form. And again, when you're asked to do that, you're going to go ahead and always start with factored form first and then just multiply it out to get standard form. And it's asking you for a possible equation, meaning that potentially there could be a different answer by a factor of a constant. But in the end, as long as you have all the key points accounted for, that's really what we're looking for. So let's take a look at the first two here. Notice that I highlighted the asymptotes in yellow. I marked off any holes in pink. I marked off the y-intercepts in blue, and then the zeros in green. So we're going to go ahead and write an equation for each of these, and we can just call it f of x, or we can rotate them from equation to equation. That's, we'll see how it goes. So we know that this is going to be a fraction, obviously. And in terms of where you start, you have a couple of different options. I'm going to go ahead and start with the vertical asymptote. The fact that there's a vertical asymptote at x equals -3 is how I know there has to be an x plus 3 in the denominator. The fact that I have a 0 at +3 is how I know there has to be an x minus 3 in the numerator. The fact that I have a hole at x equals -2 means that I have to have a common factor to the top and bottom of x plus 2. Everything else, in terms of the y-intercept, in terms of the y value of the hole, I have really only designed these problems so that they will work out nicely. So if you were to go ahead and FOIL the top and FOIL the bottom, you're going to get x squared minus x minus 6 over x squared plus 5x plus 6. And then if you go ahead and confirm all the other things that need to be true, you need to have a horizontal asymptote of y equals 1. And as you can see, 1 over 1, that would work. You have to have a y-intercept of -1, so -6 over 6, that would work. So after you hit the key points that are highlighted, you kind of want to just work backwards and double check that everything works nicely. How about over on the graph on the right? So again, let's close one, g of x for fun. And again, it's going to be a fraction. Notice there are two vertical asymptotes. The fact that there are two vertical asymptotes means that I'm going to have a factor in the denominator for each. So x plus 4 and x minus 3 are going to give me my two vertical asymptotes. Then in the numerator, those are my zeros. So in order to get -2, I'm going to need x plus 2. And in order to get +1, I'm going to need x minus 1. Again, if you now go ahead and multiply that out, you want to see that you're going to get x squared plus x minus 2 over x squared plus x minus 12. And then take a look at all the different things just to make sure they all make sense. Again, you have a horizontal asymptote of 1, which 1 over 1, that's going to work just fine. The y-intercept is just a little bit above the origin. So based on our equation, the y-intercept would be -2 over -12, which would be 1/6. And I think 1/6 is a perfectly reasonable estimate for what that graph says. So far, so good with the first two. Let's go ahead and take a look at the next two. So over on the left here, let's call this one p of x. And again, you can call them whatever you want. I don't even know if it's said. All right, so again, I'm going to start with the vertical asymptote. In order to get 4, I know that there's an x minus 4. In terms of the 0, which is in green, that looks like -1/2. And if it was a test or a quiz, I'd have to tell you for sure, and it is -1/2. Then notice that there's a hole at x equals 3, which means that I have to have an x minus 3 on the top, and I have to have an x minus 3 on the bottom. And of course, I've done so many of these that at this point, I'm able to just do these in my head without my list. Where is the common factor? What about the non-canceling factor? So again, we're kind of hoping that all the work we've done over the last few days is ultimately leading you to be able to answer them maybe without looking at the list. So then again, just go back and make sure that everything else makes sense. The horizontal asymptote is supposed to be at 2. This is a coefficient of 2 over 1, so that's good. The y-intercept is just under the origin, which based on this would be -1/4, which again, I think is perfectly reasonable. Last but not least, let's call this one w of x. And there's an asymptote at 1 for the vertical, so that's going to be x minus 1. Then there is a hole at -1, so I'm going to need an x plus 1, followed by an x plus 1. If you take a look at what we have here, again, the horizontal asymptote is here at 0. If I was to multiply this out, I would get x plus 1 over x squared minus 1, difference of squares. If you then go back to see whether or not your answer is accurate, the horizontal asymptote checks out because the degree is bigger in the denominator. That means that the horizontal asymptote will be at 0. The one thing that is not copacetic is the y-intercept. The y-intercept is supposed to be -4. Based on the equation I have, it's -1. So how do you take that and scale it? Well, you basically just multiply by 4. If you're multiplying by 4, you should do it in the numerator. You could also put it out front, but it just makes more sense to put it in the numerator. So again, you really just at the end want to go back and check that your horizontal asymptotes and your y-intercepts all make sense. So now, before we again go to Graphtown, let's just go ahead and do a little bit more of a graph analysis. So you're going to complete each of the following statements using the graph of the function. What we're doing here is we're trying to find some values as x is approaching various things. We want to think about where are the y values approaching. Now, I didn't just pick these values at random. So here's my equation, 2x squared minus 5x minus 3 divided by. I'm going to keep all that in mind about how the graph would be created. They're telling you that the coordinate of the whole is 3/7. And then they're asking you to find the following. So when they ask you as x goes to -infinity, that means that as the x gets smaller and smaller and smaller, what is happening to the y's? And as x gets smaller and smaller and smaller, you can see that you're going to travel along that asymptote, which means that the graph of f of x is actually going to 2. Remember that when we talked about horizontal asymptotes yesterday, I told you that they were also referred to as end behavior. And the reason why they are referred to as end behavior is because they tell you most accurately what is happening at the ends. When we're talking about x going to +infinity, again, we're talking about x getting bigger and bigger and bigger. What's happening to the y values? Well, again, they appear to be traveling along that asymptote, which is why we would say 2 for both. Then notice in the next set of problems, they are asking you about values of x as you approach 3, and you're approaching it from the left and the right. So as you approach 3 from the left side, what y value are you heading towards? And as you approach 3 from the right side, what y value are you heading towards? Well, luckily for us, you're both heading right for the whole, the y value of which I told you was 7/5, which means 7/5 is the answer for both. Then you're talking about the value at -2. And if you're talking about the value at -2, you're talking about what's happening as you go from the left and the right. So as you approach -2 from the left, that means you're approaching it from here. And as you approach -2 from the right, that means you're approaching it from here. So as you're approaching -2 from the left, the graph is going up, up, up. How high can you go? +infinity. As you approach -2 from the right, how low can you go? -infinity. When it comes to domain, remember, you're going to go from left to right, starting at -infinity. You're going to break for vertical asymptotes and holes. So you're going to break at the vertical asymptote of -2. You're going to go from -2 to the x value of the whole, which is 3. And then you're going to go from 3 to infinity. When it comes to the range, that's bottom to top. You're going to start at -infinity. You're going to stop first at the first y value of the whole, which is 7/5. Then you're clear from 7/5 all the way up to the horizontal asymptote, which is 2, and then 2 to infinity. So again, very important that you're trying to tell me what is happening to the graph at each of these locations. I'm not sure how often I've used the word yet, but what you're actually finding in those cases are limits, and we're going to talk much more about that. So let's go ahead and try the next one. Again, in this case, they're telling you that the coordinates of the whole is -3, 1/2. we're going to start by saying what's happening as x goes to negative infinity and what's happening as x goes to positive infinity. So as x goes to negative infinity, it appears as though it is following that horizontal asymptote in both directions, which is 1 and 1. And again, that's exactly why we call it end behavior, because it tells you exactly what's happening at the ends. Now let's pick -3 to the left and to the right. So -3 is here from the left and to the right. And as you can see, you're again approaching the same value from each side. So that's a half and a half both ways. Finally, you're going to be approaching 1, and 1 is where the asymptote is. So here's what you're looking at when you're looking at a left-handed approach, and here's what you're looking at when you're looking at a right-handed approach. So when you're approaching from the left side, the graph is going down, down, down. What's the lowest you can go? Well, that's negative infinity. As you're approaching 1 from the right, you're going up, 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 and that's going to be positive infinity. So whether or not the two sides are approaching the same value matters. Those are called left hand and right hand limits, which again, we'll get to. But for now, just a little teaser. When it comes to the domain, go from left to right, breaking for holes and asymptotes. So negative infinity all the way to the hole, -3, -3 to the vertical asymptote, and then the vertical asymptote to infinity. For the range, starting at negative infinity, then stop at the hole, which I told you had a y value of positive 1/2. Then from the hole to the horizontal asymptote, and then ultimately from the horizontal asymptote to infinity. So I think these questions are great, and they really are a great setup for what you're going to have to do with limits, which we're going to get to sooner rather than later. And then finally, kind of what you've been waiting for, we're now going to ultimately try to go from start to finish. Can you create a graph? Can you create a graph using all of the information that you have found in the last couple of days? So just a word of warning. So your graphing calculators will create for you graphs, but they're not always incredibly reliable. Obviously, asymptotes don't show up on the graph. And then sometimes they don't show how far they actually go in either direction. So while you might be using your graphing calculator to help, I would just be really, really careful about, just using that without using any of this backup stuff. So the first thing that I want to do here is I want to go ahead and find the equation of the function in factored form. So I'm going to go ahead and factor the top, and I'm going to go ahead and factor the bottom. Keep in mind, there could be circumstances where they don't factor, but the truth is that's not really very much fun because you can't really find much. So easier to factor on the bottom, factors of 3 that add up to be 4. That's 1 and 3. Then on the top, I know I'm going to have a 2x. I know I'm going to have an x. If they're going to multiply to be 3, then I know I'm going to need a 1 and a 3. And if I look at my signs, I'm looking at 2x minus 1, x plus 3, and then x plus 1, x plus 3 on the bottom. And again, if it takes you longer to factor, either using the AC method or any method, as long as you can ultimately factor, that's the goal. Are there any vertical asymptotes? And explain how you know. So a vertical asymptote is a non-canceling factor of the denominator. The non-canceling factor of the denominator is x plus 1. You would set that equal to 0, which means you're ultimately going to have a vertical asymptote at -1. Are there any holes? Why or why not? And what are the coordinates of the hole if there is one? So in order for there to be a hole, there has to be a common factor. So does there any holes? Yes, because of the common factor. I'm just going to leave a little bit more room. So the common factor in this case would be x plus 3. If you were to set that equal to 0, you would get that the x value of the hole is -3. You would then have to plug that -3 into the reduced form. So the reduced form would be 2 times x minus 1 all over x plus 1. That looks like -6 minus 1 is -7 over -2. So it looks like the coordinate of my hole is going to be -3, 3.5. That's equal to 7/2. Let me just highlight a little bit of this information. So here is my vertical asymptote, and here's my hole, -3, 3/5. or sorry, 3.5. So then horizontal or slant asymptotes, and explain how you know. So in order to determine that, you have to look at the degrees. Notice that they are both the same. So that's how I know that there is a horizontal asymptote, and that's because they have the same degree. So that means there is going to be a horizontal asymptote at y equals the coefficient of the numerator over the coefficient of the denominator, which means I'm going to have a horizontal asymptote at 2. The zero of the function is the non-canceling factor of the numerator. So 2x minus 1 equals 0, which means that x equals 1/2. I personally think it's much easier to find domain and range after you make the graph. So let's go ahead and do the graph next. So when you go ahead and start creating the graph, you're going to go ahead and start by graphing all of the information that you just found. So you found a 0 at 1/2. You found a vertical asymptote at -1. And again, it doesn't really matter the order that you draw them in. Okay, we know that there is a horizontal asymptote at 2. We know there is a hole at -3, 3.5. So -3, 3.5, you're going to literally draw that as an open circle. And then you kind of want to try to get as precise as possible. So one thing that we haven't yet found is the y-intercept. Remember that the y-intercept is always the ratio of the constant terms, which would be -3 over 3, which would be the point 0, -1. The truth is, now that I've seen so many of these problems, I actually know what the graph is going to look like because of the fact that I can only cross the x and y axis at the proper locations. And I know there's only 2 pieces to the graph because of the fact that there's only one vertical asymptote. But when in doubt, you can always find more points. Pick any x. Let's say I pick -4. If I plug it back into the equation, I'm going to get a 3. That's going to give me the point -4, 3. Let's say that I picked the point -2. I would get 5. If I was to pick more points or fewer points, no matter what, I would get one branch of the graph that looks just like this. And now I'm going to do similarly on the right. Again, the points I have are good. Let's say you were to pick others. Well, if you were to pick 2, you would get 1. And again, because of what the graph has to look like, it has to travel along the vertical asymptote, go through the x and the y axis. And then remember, the whole reason why we call horizontal asymptotes end behavior is because you are not ever allowed to cross them at the ends. So that is a perfectly good graph. How many points do you have to have? Well, I would clarify on a test or quiz. For now, all the key points plus a couple of extra. And then going back to the domain and range. So domain is -infinity. Stop at the hole, -3. -3 to the asymptote. And then the asymptote to infinity. For the range, bottom to top. So -infinity to the horizontal asymptote. Then from the horizontal asymptote to the y value of the hole. And then from the hole to infinity. So it's not necessarily a fast process. There's a lot that's going on here. But again, your goal is to try to make a well-defined graph. So you're going to kind of try and do that as very best you can. Let's go ahead and take a look at the next one. So same exact list here, and we're going to go ahead and follow it all the way through. So the first thing you're going to do is you're going to go ahead and factor. Factors of 8 that add up to be 6 would be x plus 2 and x plus 4. So how about the vertical asymptote? The vertical asymptote comes from the non-canceling factor of the denominator, which would be x equals -4. And yeah, it says explain. I mean, the truth is, if you explain it once or even twice, I'm sure you've got it. So x equals -4. Are there any holes? Yes, there is. It's because of the common factor, x plus 2, which means that the x value of your hole is -2. That means you're going to have to plug -2 into the reduced form, and the reduced form would be 1 over x plus 4. So that's 1 over -2 plus 4, which means that your hole is going to be at -2, 1/2. And again, just to highlight the things that we have found so far. When it comes to any horizontal or slant asymptotes, notice that the degree of the denominator is greater than the degree of the numerator. And hopefully you remember that that means there is a horizontal asymptote at 0. To find the 0 of the function, you're going to set the to find the zeros, you're going to set any non-canceling factors equal to 0. Since there aren't any non-canceling factors, there are no zeros. So there are no non-canceling factors. So no zeros. Again, domain and range, I would wait until after I graphed everything else. So from here, I know that there is a vertical asymptote at -4. I know there's a horizontal asymptote at 0. I know that there are no zeros, but there is a hole at -2, 1/2. From here, I'm going to go ahead and find the y-intercept. And to find the y-intercept, remember, you're going to do the ratio of the constant terms. So 2/8 is going to give you 0, 1/4. So that would be right here. And then again, you can find as many more points as you want, but the truth is you kind of see what is supposed to happen here. There are going to be 2 branches to the graph, one of which has to travel, that's a little too thick, sorry, one of which has to travel along this vertical asymptote, head towards the hole, then go from the hole to the y-intercept, and then travel along the horizontal asymptote off to infinity. On the other half of the graph, you're going to need to go ahead and at least just find maybe 1 point. So I'm going to choose, let's say, -6. Just so you know, when you're trying to find the y value of any additional point that you pick, you can plug it into either the original or the reduced form. You'll get the same answer either way. I'm going to pick the reduced form because that's just easier. So 1/x+4 is going to be 1/-6+4, which is going to be 1/-2, which is going to be -1/2. And again, that single point right there, because of the fact that I have to follow these asymptotes, really is enough for me to draw my picture. And again, in the future, I will tell you exactly how many points you need. Again, pointing out the end behavior, the fact that you're not allowed to cross the asymptotes, and you do have to follow the horizontal asymptotes off to infinity. Domain and range. So domain and range. For the domain, you're going to go from -infinity to -4, -4 to -2, and then -2 to infinity. For the range, -infinity to the asymptote, which is 0, 0 to the whole, which is 1/2, and then 1/2 to infinity. I know this is getting a little long, but the graphs can look all kinds of different ways, so it is important to try them, and hopefully you get faster the more you do of them. So let's go ahead and start by factoring. Factoring the numerator only looks like x-4, and then looks like x+2, all divided by x. So vertical asymptotes set the denominator equal to 0. Wholes come from common factors, of which there are none. When it comes to horizontal or slant asymptotes, there is going to be a slant asymptote because the degree of the numerator is greater than the denominator by exactly 1. Remember, you're going to copy your coefficients. You're going to set x equal to 0, or set the denominator equal to 0 and solve. So it turns out 0 is going to go in the box. Bring down the 1, 0, -2, 0, -8. You would then have to divide by the coefficient of the denominator, which is just 1. And then again, this is weird, we've never really put 0 in the box, but it still works. You're going to look at that 1, look at that -2, which means your slant asymptote is going to be y equals x-2. So horizontal and slant. How about the 0? So the zeros come from setting each of the non-canceling factors of the numerator equal to 0. which means you're going to get x's of both 4 and -2. Let's go ahead and put that all into action on the graph. So starting with the vertical asymptote, that is at 0. Then each of your two zeros, which are at 4 and -2. And then you have to graph y equals x minus 2. So that means start at -2, up one, right one, up one, right one, as many times as you can fit on the graph, and down one, left one, as many times as you can fit on the graph. And you do want to try to be as precise as possible. There is no 0. If you try to find the y-intercept, you're going to realize that the constant on the top is -8, but the constant on the bottom is 0. So that means there is no y-intercept. So no y-intercept, no x-intercept. Again, maybe you know what the graph is going to look like, but if you want to find a couple of additional points, you certainly can. So let's say that I plugged in -1. Whether I plug it into the original or the reduced form, I'm going to get a +5. If I plug in -4, I'm going to get -6. I'm going to get -4. Just trying to save a little bit of time. So -4, -4. And then hopefully you can see that you're going to have one piece of the graph that looks like this. The other piece of the graph should go the opposite direction, but if you want to be sure, plug in 1, you get -9. Plug in 2, you get -4. And that's really kind of enough for you to get the job done. So point here, graph starts at the bottom, heads up, crosses through the 0, and then travels off to infinity. So looks a little different, certainly harder than the graphs we've seen so far, or maybe not harder, just different. And then finally, domain and range. So for domain, from left to right, the only place we have to stop is the vertical asymptote. And then for the range, notice that we don't actually have to stop anywhere. There are no horizontal asymptotes. There are no holes. So that means that the graph just goes on forever in both directions. And finally, last but not least, let's go ahead and finish up our final example here. So we're going to go ahead and factor all over the place. And if we factor the numerator, we're going to get an x minus 6, followed by an x plus 3 over x plus 5 and x minus 5. So vertical asymptotes, yes, there are. And in fact, there are two of them. So x plus 5 equals 0, x minus 5 equals 0. You're going to get vertical asymptotes for which there are two, plus and minus 5. Are there any holes in the graph? So there would only be a hole if there was a canceling factor, of which there are not. When it comes to horizontal and slant, look at the degrees. Notice that they have the same degree, which means there's going to be a horizontal at the coefficient of the numerator over the leading coefficient of the denominator, which means y equals 1. The zeros come from setting the non-canceling factors of the numerator equal to 0, which are 6 and -3. If we go ahead and put all of that on the graph, so there's a 0 at 6, there's a 0 at -3. Here's my horizontal asymptote at 1. And then I need -5 and +5. This is the first time that we have graphed by ourselves from scratch a graph with two vertical asymptotes, but that means there's going to be 3 pieces to the graph because each vertical asymptote cuts the graph. The y-intercept, that's going to be -18 over -25, which is going to be 18 over 25, which is a little bit less than 25 over 25, which is a little bit less than 1. So keeping all that in mind, again, I can kind of see the graph taking shape. If you can't, plug in a couple of extra points. I'm going to plug in something like -6. If I plug in -6, I would get 3.3. That's how I know that that piece is without a doubt above the asymptote, which means here is piece 1 of my graph. For the piece in the middle, I have a 0 and I have a y-intercept. Let's say that I want to know where it starts. If I plug in -4, I get -1.11. That's down here. If I plug in 3, I get 1.12. That's here. which means this is an example of a graph that starts facing negative infinity, goes through the points, goes through the 0, goes through the y-intercept, and then ultimately winds up crossing that horizontal asymptote. Finally, the last piece has to start facing down, ultimately go through the 0, and then head off to infinity for the x. So there are 3 pieces. Again, when it comes to horizontal asymptotes, you can't cross them and you have to follow them at the ends. Notice that we did cross in the middle because a horizontal asymptote really only talks about the end behavior. So, man, there was a lot going on there, but I'm confident that you're with me. So please try homework 24 tonight. You'll see it's very similar. So thanks very much for tuning in, guys, and we will catch you next time.